So first of all, in networking, it is the interface of a network equipment that have IP addresses. Machines by themselves do not have any IP addresses, right? So it is always the interfaces that have IP addresses. So IP address or MAC address are actually the property of interface of a machine, right? But there should be some way to identify the machine uniquely and of course deterministically through IP addresses in the network. So for this purpose, we create a special software interface called loopback interface on the machine and we assign an IP address to it. So remember, loopback interface are software interfaces. Now what does that mean? It means that loopback interface is actually not a hardware, but loopback interfaces are software based interfaces and therefore you can create as many as you want. So on a given machine, you can create as many loopback interfaces as you want, right? Because loopback interfaces are actually the conceptual concept. They are actually not a physical interface or they are not a hardware. So on a router, you have slots. In these slots, actually you insert the interfaces. And these are physical interfaces that you need to buy from the market. We call these interfaces as NICs. NIC means network interface cards. So these are actually a physical piece of hardware that you need to buy from the market and insert it into the slots of the router. So loopback interfaces are not a hardware. It means that there is some piece of software running on the router or a network device and that piece of software simulates as an interface to the operating system. So because loopback interfaces is simulated by a software, therefore you can create as many loopback interfaces as you want on a network device. And you can assign IP address to those loopback interfaces. So since loopback interfaces are a software interfaces and they are not hardware interfaces, therefore they are not prone to hardware failures. So anything that is not hardware is obvious that it will also not fail. They will not wear and tear out over a period of time. So because they are not hardwares, therefore loopback interface possesses the property of high availability. That is, suppose on this router, this slot or this interface fails, right? So this interface will go down. But loopback interface is a software based interface and the probability of failing of a software is way less than the probability of failing of a hardware, right? So loopback interfaces that is created on this router will always be up and running most of the time and therefore loopback interfaces possess the property of high availability. So high availability here means that because loopback interfaces will be up most of the time, the remote machines in the network can always send a packet to this machine using a loopback IP address as destination IP address in the packet. Therefore, if A, that is machine A, creates a loopback interface LO1 and assign an IP address to it as 12.1.1.1/32, and there is another machine B in the network which creates a loopback interface LO1 and assign an IP address to it as 13.1.1.1/32, then A can always send a packet to B with source IP address as 12.1.1.1 and destination IP address as 13.1.1.1. And our IP rule is still valid. So what was our IP rule? That machine A can send a packet to the machine B only if machine A specifies the destination IP address in the packet as IP address of one of the local interface of machine B. So in this case the IP rule is still valid because at the end of the day the loopback interfaces also are local interfaces of the machine on which they are created. So it is a good practice to assign the source IP address as IP address of loopback interface of source machine and the destination IP address as IP address of loopback interface of destination machine. Loopback interfaces are not used for any traffic exchange. It serves the purpose of device reachability in the network. So this is the important property of loopback interfaces. So remember, loopback interfaces are not a hardware. Therefore, loopback interfaces cannot transmit or receive the traffic or the data from other nodes in the topology. But the remote machine can send a packet to another machine in the topology by specifying the loopback interface of the destination machine as destination IP address in the packet. So that means the loopback interface can be used for device reachability. So you can see, for example, machine A can send a data to the machine B using B's loopback address as destination address in the packet. And once this packet reaches to machine B will consume the packet. So there is no such thing like B will forward the packet out of loopback interface, because loopback interface are conceptual concept. So B do not forward the packet out of loopback interface because there is no such thing, and loopback interface is a conceptual concept and it is not a physical interface. Right? So the packet that arrives on B with the destination IP address is equal to the IP address of the loopback interface. Such a packet will be locally processed by the machine B. So guys, going forward, we can view the loopback interface as just another interfaces, right? And loopback addresses itself is one subnet with mask value always 32. So let's try to understand these 2 points. So you can see that in the below topology there is a router R, right? And it has 2 physical interfaces. So the subnet ID of physical interface Ethernet 3 is 192.168.1.0/24. So let's call it as subnet A, right? And the subnet ID of physical interface Ethernet 2 is 192.168.5.0/24, and let's call it as subnet B. So you can see in this diagram how many local subnet does this router have. The answer is 2. That is, subnet A and subnet B both are the local subnets to this router. And because these links are actually physical links, therefore there could be other machines present on the other side of these links, right? Now let us try to visualize how loopback interface logically looks like to the topology. So I have added one interface to this router, and this is loopback interface with the name LO1. So loopback interfaces also have the MAC addresses, and they are configured with the IP addresses. So you can see that any IP address that is assigned to the loopback interface always has a mask value of 32. Loopback interfaces do not have a mask value other than 32 for IPv4 addresses. Now let us try to apply some IP address mathematics on the loopback IP address. So we have a loopback interface 1 which is configured with the IP address 122.1.1.1/32. Now we have already learned how to calculate the network ID. So apply the network ID mathematics, you will find that the network ID of this interface is 122.1.1.1/32. And we already know how to calculate the broadcast address. So the broadcast address of this interface is 122.1.1.1/32. So you can see that for loopback interfaces, the network ID is same as broadcast address is same as the IP address that is configured on the loopback interface. Now I will ask you one question. How many local subnets does this router R have? The answer is 3. One local subnet is A, another local subnet is B, and the third local subnet is 122.1.1.1/32. Because router R has 3 local interfaces: the interface Ethernet 3, the interface Ethernet 2, and the interface loopback 1. So the number of local subnets for this router is 3. If you create another loopback interface on this router, then the number of local subnet for this router will be 4. And loopback subnets. So what is the network ID of the loopback interface? This one, right? So I want you to apply the definition of local subnets and remote subnets in this case. You will find that the loopback subnets are always the local subnets for the local router, and loopback subnets are always the remote subnets for any other network device in the topology.